So I'm here to talk today about getting the most out of your cloud resources for your business. And I'm going to talk about this from the perspective of a software as a service company CEO who runs a business across basically all of the cloud platforms. So for those of you in the IT pro business, this would be, I think, some things that you could look at running and implementing for your customers. For those of you working in IT departments for companies, we've gone through a move and transformation in my business that we'll talk about that has gotten us through to operating on multiple clouds in a way where we get benefits from that diversity rather than just complexity and headaches. Okay, so I'm going to take a little bit of an opener here for some fun and be a little bit maybe offensive. So how many folks think cloud computing is the only choice for infrastructure on a new project right now? Okay, there's two of us. It's good. I'm not alone. So when I say this, and this is a little bit of a push out there and a prod, but let's go back 30 years. And how many folks in here used to build servers and assemble them yourselves and get motherboards and deal with UART conflicts and jumper conflicts in the motherboards and all this? How many people in this room build servers today? Okay, how many people work at Dell? Nobody here yet. If somebody works at Dell may be building servers still, but if you're not working for one of those big server providers at this point, you probably shouldn't be building servers at this point in time. And this market went from all of us building them, it went from a whole bunch of companies and competitors out there in this market building those devices on through to now where there's basically three big competitors. And the reason we all buy from them is the scale, efficiency, and consistency they have allows us to deliver a better outcome ultimately to our customers and clients. Now, at the same time, those big three server vendors realized, well, crud, if my server's just the same as the next guy's, what am I going to do? So how many folks dealt with over the last 20 years where you've got environments that have DRAC cards from Dell, ILO cards from HP, and you're trying to figure out how to do management of both of these kind of servers through one management platform? There's got to be at least a couple of y'all here and there on that one. So similar situation now as we fast forward to cloud computing. So there's a whole bunch of hosting companies out there. Many of those hosting companies built cloud platforms. We're pretty much down to a big three on the cloud now with Amazon, Google, and Microsoft. You were looking for anything? No, you're just over there. Okay, cool. Just making sure I wasn't breaking something. I am known to do that from time to time. So on this, timeline-wise for the cloud, everyone goes, you know what, this is just a brand new thing. It hasn't really been around that long. It's actually kind of gone along. If you consider hosting, and cloud being someone else's data center with servers in it, it goes back a full 20 years at this point. And many of those early vendors in the space were out there assembling their own servers. Rackspace, who I worked for at a point in time in the past, AT&T, who I worked for before that, we all had internet data centers that we had set up. And even at one point, AT&T was SBC back as you go through the phone company history, but we were even building servers to a certain extent there. Rackspace had famous designs for doing super efficient racks full of white boxes when they first came out. And now you look at these big cloud vendors and they're all building their own infrastructure. And they're doing it in a way that is at more scale than even the server vendors that are selling individual servers to you and I at this point. Google's famous for having a network fabric that is a bigger fabric backplane than anything made by Cisco or any of the other networking vendors is just one example. So I'm going to say goodbye to the server closet. Now, how many folks recognize things that look like this? You walk into a business and you see this. Yeah, I don't ever want to spend time on this stuff again. The public cloud makes it easier for you to get projects done in a timely manner. It makes it easier if a business has a new IT plan and project and idea, and they don't know if it's going to be successful. They've got a 12-month business plan. It's hard to buy hardware on a 12-month lease and just return it back to somebody. So it makes it easier for businesses to start new projects and repurpose and redeploy if it turns out to either be more successful or less successful than the initial plan. Another benefit here is if you just got hired in to be the IT pro to work on this, and this is what you have from a cable mess, and you don't have any documentation, how long is it going to take you before you're afraid to move, before you're willing to move one of those wires? So the onboarding process and being able to come in and make an impact in your own job from a cloud perspective, even if your predecessor has not done a great job of documenting things, there's going to be information in their logging tools and the control panels and the systems. You're going to get a minimum baseline that makes it easier to come in and become productive quickly. Okay. So now everyone says, okay, well, back in the server world, I hated dealing with the difference between DRAC and ILO and trying to deal with all the complexity of that, so we just standardized our whole shop on one server vendor. How many folks went that route or tried to? A whole bunch. So we're going to do the same thing in cloud. We're going to standardize on just one cloud vendor. Except if you standardize on one cloud vendor, you're standardizing on one server vendor, one networking vendor, one everything vendor, one data center provider, one everything. So it simplifies things a whole bunch, but it can create some challenges for you from a business continuity and risk perspective. So I'll break the different types of applications down into three categories and to help facilitate the conversation. These are fairly standardized industry categories, but a tier 1 app, this is something that's absolutely mission critical to the business. If this thing goes offline, stuff stops. So let's say I'm a big chemical company and we're running a big chemical plant, and I've got stuff running through, and I've got a software app that's printing labels to go on these chemical bottles so that we can then put them into a crate and we can go ship stuff out, and it prints the bills of lading and does all that stuff and schedules the delivery trucks. That thing goes offline, you have to shut the factory down. So these type of tier 1 apps, the idea of having that in a single data center on a single cloud provider, and you can do multi-data center with a single cloud provider. I'll talk about that a little bit as well. I'm not a huge fan of. If this is a real big facility and you're talking about orders getting backlogged and in the tens of thousands of dollars of minutes per minute level or even more, at that point, it's likely worth the complexity of multiple discrete cloud providers. I think if you look in the history over the last few years on the cloud side, Microsoft, Google, and Amazon have all had different types of outages on different days. If you go back into the server hardware world, Dell had problems with a PERC RAID controller card. HP has problems with their cards every once in a while. And so for these tier 1 apps, even back in the day, ideally you were building your own environment with multiple server vendors, and you should be doing the same today from a cloud perspective. Tier 2 app is one that has real-time business impact, but it's not shutting a whole factory down, shutting the whole company offline. So this might be Jira. If Jira was offline and we weren't able to work our IT issues, or if your source code repository was down, your developers can't work. So it's impacting the business in a way. It's likely not directly customer-facing, and it's for a department, but it's certainly something from a productivity perspective. You don't want an IT team sitting around unable to work issues. You don't want developers sitting around unable to get to source code. You don't want an HR team that can't look and screen open job apps. So if you go through all the different kind of departmental apps across the company, that's what I call a tier 2 app. And then a tier 3 app, these are ones that are on an ad hoc usage pattern. So say you have something it's a monthly report, it's due by the first Tuesday after the month close. If that was down for 3 weeks, no one's really going to notice. It's just offline. It doesn't have to be used then. Even if it was down on that during that first week where you had after the month to hit the button once and run the application, it's fine. Now, if whoever was supposed to use the app waited until Tuesday morning, the day it was due, then it's going to have a real-time business impact. But there's many of these types of jobs that if they run at different points during the day or week or month, that an outage or an impact on that won't make a difference to the performance of the business. So I like cute cartoons every once in a while. So we've got a little deployment matrix here. So single cloud provider, single data center with them, single region. I'm going to refer to them as regions. Real simple. It's addition. Like, we can all do that one. From a complexity perspective, going from single region to multi-region on the same provider is not that much more complicated. You're going to be inside the same control panels, the same tools, the same APIs. So, and even at this level, everyone can count to 12 up there, hopefully. But even if you didn't know multiplication, you could do 4 by 3 and get to 12. The single provider, multiple regions, not that hard. Now, as soon as you go across to multiple providers, now we've got some more complicated things that we have to deal with. You've got to be able to convert from one to the other. So here, throw up a little circle. You got to be able to do some math to go from that diameter to the radius to figure these different things out, the circumference. It's getting a little more complicated. Once you get up to multiple providers in multiple regions, now you have a substantial level of complexity where you're even likely introducing external systems and monitoring tools to be able to run and manage that, to be able to determine where the faults are and how to handle them. So for a tier 1 app, ideally, you go all the way up to that multi-region, multi-provider. This is in a larger company, larger revenue stream. If you're, again, something that's in the thousands of dollars of downtime, you're probably worth being up in per minute, per day, up in that multi-provider, multi-region. If it's a smaller company and a smaller app, tier 1, absolutely, single provider, multi-region. Unless you want to be the one explaining to the business leader why everyone is sitting around doing nothing or why we can't ship stuff out of our facility or all the rest of those problems you would have with a tier 1 app not functioning. For the tier 2 apps, I don't recommend going multi-cloud. Stay on the single provider, but go to multi-region. And you should be able to design the architecture in a way where that multi-region deployment is not substantially more expensive. As soon as you start to get into departmental apps, folks will get much more business conscious on like how much do we have to run this app, how much can we afford, is the redundancy something that's inside of our budget. You can do single provider multi-region in a way that should be budget efficient. Even if it's just, especially with cloud, you can replicate the database and the data stores across to the second region. Maybe you don't actually have all the front end servers spun up, so you're running in an active passive, but because it only takes a few minutes to launch VMs and have your front end running in the second region, you can run with just that data replication on the normal day basis, and then with monitoring in place, you can put the front end up, cut the DNS over to the new front end IPs, and you're up and going in a matter of minutes. And generally for a tier 2 app, that's acceptable, and it's a way you'll be able to get through the budget piece you need. And then on a tier 3 app, single provider, single region. These apps you want to keep, you likely, in a medium or large organization, you have tons of these around. You even have them running on employees' laptops, especially employees in your finance department. You might not think it's a tier 3 app, but they've got an Excel spreadsheet that is a database that has code in it that connects to external data sources, and they're all running tier 3 apps on their computer. Ideally, you would like to get those things maybe off of their laptops and into some batch processing system for them. Some of the Office 365 stuff's making it easier to go do that now, but these are great conversations. But you don't want to add the complexity for these tier 3 apps of multi-region even or multi-provider. There's just so many of them out there. Herding those cats into a just more consistent, normal, constrained environment rather than all the places they're scattered around right now inside of a business is likely a better return on your time and investment there. So I'll start on the happy side. If you can run multi-cloud, multi-region everywhere, the odds that both Google and Microsoft, or Amazon and Microsoft, or Amazon and Google are all down at the same time, really, really low. So if you've got a globally set up, global load balanced, geo-redundant app running across both of those clouds, chances that everyone is out and you're unable to do business is really, really low. You may have some additional sessions if you've got sticky sessions or things inside of an app that get dropped, or you can actually replicate the sessions across. Just depends on how advanced you want to get on that high availability. As you're copying those things back and forth, and you're trying to manage them, if you have users in multiple locations, managing some of the latency for them can get a little bit more complicated, and from a regulatory compliance perspective, if you have reports you have to fill out about where's my data stored, how's it stored, some of that regulatory piece will become more complicated with the multi-cloud and multi-region. It will also allow you to store data where you need to. So if you have French citizens, you may be able to store your information in a French cloud facility so that you're making them happy with their data privacy laws, or Australia or a number of the other countries that are a little bit more thoughtful about data privacy and PII. And then on the third one, if you're running on multiple clouds for some of your tier 1 apps, you can then pick and choose between the clouds for your tier 3 apps, because the Google App Engine might be amazing for something. On Azure, the Azure sites might be amazing for other things. Amazon's got a whole ton of microservices that might be amazing for something else. We run some stuff inside of SQS ourselves as an example. And you can pick and choose those for those tier 3 level apps. Now, if you go to these multi-cloud, now people have to understand how they all work. So more complicated training time. If you're an IT professional and you can do multi-cloud, then that's good for your career and your skill and your pay and your wages. But if you're a business owner, that means you're hiring more senior folks that will command a higher salary in the market. The number 2 on that drawback list is kind of the most tricky one. And this is the identity and access management issue. So a lot of the ways that the cloud providers are looking to lock you in, the way that the server vendors did with their server out-of-band access, is through managing identity and access differently on each of these and not making it so wonderful to be able to federate between them. So while there's all sorts of SAML and OAuth and all sorts of things, the federation out there, and we're not seeing at this point, at least from talking with my tech team, a real clean and easy way to manage your administrative access and all of the different rights and usage across all of the clouds. We're going in doing manual usage and rights management and configuration on a lot of things at the administrative level. And then down at the our virtual servers, we use a across-the-board dynamic SSH key deployment that just puts the keys on the servers for the time that they need to be there for someone to get a login session. So they basically go ask for a session on there, a bastion deploys a key out, they get to use that key while it's there, and then as soon as they're logged in, that key gets deleted and pulled back off the server. So that standardizes our access across all the clouds, but from an administrative identity and access management, it's different on all of them. And then the number 1 on the multi-cloud drawback is if you're going to try to deploy an app, a tier 1 app, consistently across multiple providers, then you're stuck with the least common denominator feature set. Now, the good news of that is the LCD feature set on these big 3 cloud providers at this point is pretty robust. Okay. So now I'll talk through some tips to avoid getting stuck on one of these cloud providers if you're out there already. And I'll start by giving a high-level overview of our jungle disk architecture. So we have our main websites for our website for the marketing stuff, website for users to access at My Jungle Disk, and then secure.jungledisk is the administrative access portal. Those things need to be up and running all the time. People don't like not being able to get to their data. My marketing and sales team don't like the website being down because that's bad for marketing and sales. And then across to the data platform side of things, we have client software that runs on servers, on laptops, desktops across Windows, Mac, and Linux. We have data going to and from mobile devices. And we have a management client that allows folks to connect into those servers. So those are all real-time data flows, and we're transferring data between those systems and our platform. We run then a set of flow control servers inside all of the different cloud providers, and then use the different object storage behind the scenes there. We the business runs. It was owned by Rackspace for a number of years, from 2008 until 2016. So it runs on the Rackspace cloud because they bought it and they said we're going to make it run there. Also runs on Amazon and the Google Cloud platform right now. We've done some test integrations and deploys to Azure. We haven't cut over anything production-wise over to that cloud yet, but one where we are actively evaluating and looking at that and kind of going even up to a fourth provider from an availability perspective and data sovereignty and a number of reasons. So, step one, how many folks have names on their servers where you know the name of your server? Okay. It's hard to go hard in that point to not get locked in. So that the server you've named, it's a pet, and if you've got a name for it, then it's hard to throw it away because you go, I've named it because I've got stuff on it that I can't delete, and that will start to make things more complicated between cloud providers when you have servers with specific apps and data on there, kind of bespoke installations, because now you could manually go provision on multiple clouds and have a named type of server across them. But if you're looking to really move into an automated cloud deployment, you may have a way to deploy a service. That service may have a name, but the actual servers it's running on should not be named. So, and then as you look out across these clouds, as I said, there's kind of that least common denominator feature set where they all have virtual machines now, they all have load balancers, they all have object storage, they all have external block storage, which kind of replaces a DAS or NAS, depending on how you're looking at it. I think most of them, maybe all three of them now even have a network file service, which would replace like a NetApp style file sharing or other type of file server on the back end. Now, if you get out into these clouds, you have more bespoke services. So like only Google has App Engine, and if you write an app that's tied to run an App Engine, it's only going to run on App Engine. Now, there's open source frameworks out there where you can deploy an App Engine-like stack clone on a single VM and make it run. I really wouldn't recommend doing that in production if you're going to run on App Engine on Google and a VM running an App Engine open source clone on another cloud. I would just run the open source clone on both of them. Like, if you're going to go that route and go, well, we could do this with this thing, then just standardize it everywhere, rather than have all these questions of performance differences and things. And as you go on through, things like CloudFormation, Azure Sites, and the rest of them, they all take a different aspect to look at how services run, and there's a whole giant laundry list of differentiated services across these providers now. So step two is automation. And with automation now, you're thinking about services and you're thinking about systems operating as a whole, and you're not necessarily thinking about the individual discrete components anymore. And I recommend using one of these or many of the other ones out there, but your own configuration management tool and automation system, not one of the ones specifically from the three cloud providers. So if you're going to go use a tool from the cloud provider, it's going to work really good with their cloud. Maybe you can actually even make API calls and launch something on someone else's cloud. But if your whole point was to diversify cloud providers, so if you had an outage at one of them or an issue with one, that you're not dependent on it for the other one, that's not a good idea to use their automation to launch stuff on someone else. Now, you could also go train people or train yourself and learn how to use all the different automation on all the different platforms, and then you're going to maintain each of the different automation for each cloud platform, and I wouldn't pay you as a CEO to do that. I would be really frustrated and upset with you. Might be a fun hobby project, but I don't think it's a good use of anybody's time. With automation solutions, there's kind of two different ways to think about them. One that's agent-based, so Chef and Puppet both run primarily in an agent-based mode. You've got an agent that gets deployed out on each virtual machine or each server, and then from there it maintains system state for you through a central repository. Ansible and SaltStack both run in an agentless mode. Salt also has agents if you wanted to go that route. If you wanted agent, I would go Chef or Puppet. And so this runs and remotely executes commands on systems. It does not install and leave any software permanently behind on there. And then from your own skill, your team, your pieces, the two agent-based ones both happen to be written in Ruby, and they have a Ruby set of dependencies. You're going to be putting a Ruby stack on the server. So if you were running a Ruby on Rails website, adding Chef or Puppet to that, not a big deal because you've already got the whole Ruby stack there. If you're running a Microsoft SQL server and you need to make the Ruby stack run on Windows, life can get a little bit more complicated. And step 3, containers. So how many folks have deployed an app to a container? Anybody here yet? We've got one. Okay. So containers are like tiny operating systems. And the whole idea here, this is, I mean, it's what's old is new again. So as I started off talking back about the systems and the servers, and how many folks used to burn gold images for your server build? Yeah, well, a container's kind of a gold image for whatever this service is. You'll build it and set it up in a way where you don't log in and make really patches, updates, or changes on that container. You get the service up and deployed through your source repositories, and then it just runs as an atomic unit. And if you need to make changes or updates or maintenance to it, you do that through the source repository and your automation tools and just deploy a whole brand new container again. All 3 of the major cloud providers all support Kubernetes. The acronym for that is K, the number 8, and S, if you were going to go Google or look or search around for it. It's an open source project that kind of came out of Google and out of the way they run their own infrastructure internally. And even Amazon has decided to go and adopt it, so there's an elastic Kubernetes service now at this point. So it's the one consistent container service across all of the clouds. If you've heard of Docker, Docker's another container management system and a way to deploy containers. You can deploy Docker containers to all the different clouds, but mostly what ends up happening there is it launches a lightweight VM that it then puts a container inside of that VM. So you still have some of the overall maintenance surface of that virtual machine running above and beyond the footprint of the container. With containers, this encourages you to build services in a architecture where you're separating the app and the app code from the actual data. So data at this point should be stored in databases or object storage systems or file storage systems or something, but you shouldn't be storing persistent data for an application on that app server. You might have some caching or other things that get stored locally, but if you're looking at managing data stores inside and business data, there's a whole plethora of things now, from different types of key value stores to relational databases to object storage to data archive systems. And with all of those services out there across all of the clouds, and they all have a comprehensive set of data storage options, that data should be separated out from the app code. A couple of reasons on this is like it eliminates some of the need for sticky sessions, as I talked about earlier. If you're going to cut a session over, if that one app server fails and there's a bunch of stuff about that session on that individual server, then all of those users that have their session data stored there are all going to have to start over from wherever they were at. And then the second piece is if you are in a troubleshooting spot or in a security rabbit hunt, you can start to look at the logging on the data stores. And if a hacker or an attacker gets into your app servers, you can pretty quickly get with the security team and figure out what data was accessed or was any data accessed and other things. So you can see and give some useful information very quickly to your risk team to figure out, was this a violation of an app server and an access into an app server that we'd want to have, or was there an actual data breach here where they grabbed a certain set of records and sent them off somewhere? So having that data in a store that is a separate service with logging on it will let you be able to be very clear for folks about the access patterns. So I think if we move and out and deploy to the cloud, we get from the projects running in a data center now into there, we can all ride off into the sunset here together. I will go through now for questions about any of this stuff, and I can talk from business policy down through to tech implementation details on the clouds and systems. And I think they've got a mic they're going to run around here because they're going to try to record all this. One here.
Do you see a trend in from cloud to hybrid cloud? Because this is becoming a trend right now, the hybrid versus just pure cloud.
Yeah, so from a hybrid cloud perspective, so question, for those, I'll define hybrid cloud and tell me if we're defining it the same. So this would be some of my infrastructure running in my own data center. Maybe I'm running a VMware virtualization cluster, and then I've got my baseline base load running on that, and then if I need to do flex load, or if I need to do a staging environment or a test environment, or I have more users on an app during a certain time of the year, then I add up additional information in a public cloud. Is that what you mean by hybrid? Okay, so I think that at very large scale, hybrid cloud makes sense. So if I'll take eBay as an example. They've talked about their infrastructure pretty publicly. So they run 4 data centers last time I saw a presentation on this. And those 4 data centers handle their base load. And a e-commerce site like eBay has massively varied usage patterns. So their baseline environment is about 30% of their overall traffic. And then depending on where users are coming in and what sections of the site folks are going to, they spin up resources in different cloud centers wherever they need to in order to handle the additional user capacity. I think at a much smaller scale, hybrid is really complicated. Hybrid can be more complicated even than a multi-cloud, because you effectively on your cloud have to build all of the services that are going to mirror out there in that other cloud. And if you're running I'll just say like a pretty traditional 3-tier application with some app servers, some front-end servers, and a data store, you can hybrid that pretty easily. If you're running a more complex app architecture with multiple types of data stores, multiple different front ends or microservices and different APIs that you're publishing out and making available, running hybrid can be really tricky. It goes straight up to the algebra of the multi-region, multi-provider right away. So it does make sense at large scale. Really large scale, though. I even think, so looking at other companies, I don't know that it made sense for Dropbox to try to build their own storage hardware. We'll see how this plays out over time. But I'm in the same business, and I would not want to be trying to out-engineer Amazon, Google, and Microsoft's storage backend teams. And from their hardware buying and purchasing power and everything else. I think that's a real challenge over the long run. Yeah, so that was on large apps, seismic data. So for folks like in oil and gas industry, if you're Exxon, you have 45,000 servers inside your own data center that you run on your exploration data set. If you're a smaller player, you don't have that, and you're not going to buy it and build it. You may have a small set that you run in your own facility. So for batch job processing, moving out to a cloud, that's kind of something I would call a single service and a single discrete app. Scientific processing, genome data sequencing, things where you can use the spot instance pricing or some of the commodity markets out there on the public clouds to lower your cost of processing. That type of hybrid stuff makes a lot of sense. Yeah, but even like all the large financial institutions, a lot of them run their own, they have compliance reporting that has to go out every day. And they run their own platform, but they all have failover designed to run to all 3 of the big public clouds at this point. Because if they don't turn their financial reporting in, the fines on that can be substantial. And the engineering work to be able to run those nightly batch jobs and get the reports in a timely manner was just worth it for them. Anything else? How many folks are from Austin? A few of you. Let's see. Anyone come here from Europe? Asia? South America? Yeah, we have an American audience. Unless Oceania, anywhere else that's not Europe, Asia, or South America? Antarctica? No? Okay. So we have an American audience here today. Let's see. How many folks have deployments on at least one cloud right now? So a little bit more than half the room.
I wanted to ask you, but I'm sorry.
Yeah.
Sorry. What do you consider like just moving from on-site? Like I'm a very small company.
Yeah.
Moving from on-site server like Exchange, I moved to Office 365. That's very much simpler than what you're talking.
Yeah. So small company, and so move from. Let's say you're running Microsoft Small Business Server. The 2011, I think, was that the last year they came out with Small Business Server? Yeah, so we're sneaking up on a decade there. They're probably, are they on extended maintenance on that yet? I don't know, maybe. Yeah, so moving from that, where you've got a SQL Server database, you've got an Exchange server, you're running your own mail. I think at this point, continuing to run email is becoming very challenging and problematic from a spam filtering and phishing filtering and a deliverability perspective. So there's the security aspect of it, of you have to deal with a bunch of crud coming in, you are having to deploy some other type of mail guard service on the front end. And then the other challenge is on the outbound side, the big email providers at this point, Microsoft and Google, are becoming much more restrictive about flagging your messages. So like if you're running your own Exchange server and you email me, I may get a big red banner that says warning spam risk on it because Google might decide that your small Exchange server isn't trustworthy. So from a user perspective, running your own mail server is becoming a little bit more tricky. Migrating a mail server is also really scary because that's a tier 1 app. No business wants their email offline at all. Everyone says, well, email's not real time. It's not tier 1. Oh, it's real time. That's for probably half the employees in every company, email is their work queue. Yeah. I would be looking at migrating to Office 365 or Google G Suite and running my mail from one of those platforms right now. Depending on how your users are set up and plugged into Outlook with PST files and other things, life could get complicated if you move to anything other than Office 365. If your users are just using the web interface, Outlook Web Access, to access your Exchange server right now, you could pretty much migrate anywhere. Now, these migrations should be able to be something you can do, schedule out over about a 30-day period, do a first-pass data migration over a weekend. You can set up alternative DNS, and you can go check deliverability and everything through the alternate, and then another weekend forward do the actual cutover. So, I mean, there's tons of Exchange servers that are getting migrated now. There's tons of services out there that assist and help with that migration for folks that don't do it on a regular basis. If you're in the business of doing these type of migrations for folks, there's a lot of great tools out you can buy, and you should be able to make this a pretty high margin service because running and operating that Exchange server for most companies, unless if they're sub 250 employees, is likely much less expensive for them over the long run than running on Office 365.
We've had Office 365 for 6-7 years. It's been great. You just have to be very careful. We implement the security control. They recommend like data loss and prevention, turning off mappings, native client on the iPhone. We've done Office 365. We bought Chronos in the cloud, Financials in the cloud. Last year, Trend Micro antivirus moved to software as a service. I'm left with Skype on premise, and I'm 5 hours out here. We get hurricanes.
Yeah.
So I'm trying to move everything to the cloud. So I guess I wanted to get your advice moving Teams with dialing pad as a cloud, telephone as a service. What are your thoughts? Is it stable?
Yeah, so the question, so he's made the move of many of the services. So were you on, was it Office 365 when you moved on there? Or was it BPOS, the Business Productivity Online service?
Well, it was Office 365.
Is Office, so the early,
On-premise. Now it's
Yeah.
still Office 365
Five.
with Skype on-premise.
yeah, so and he's still running what used to be Link, now called Skype, on the on-premise, on both voice, video, and chat, or all three of them?
Yeah, we got the dialing pad, the voicemail is in the cloud. You get us an attachment.
Yeah. So moving, you can move to that on Office 365. I believe it's the E5 license adds voice, or you can get a voice add-on to the E5 licensing there. And you can make that full switch and cut over. I'm not an expert on the exact feature changes you're going to get. I would suspect that there's still some features in that Skype and Link on premise that are not available in Teams or in the VoIP platform on Office 365.
But doing telephone over the internet, is it going to be stable? We're going to
Yeah. I mean, so we run a whole customer service platform. My whole customer service team runs on voice over IP. So we even have all of our call center operations at Jungle Disk on voice over IP. Our sales and everybody else are on a separate voice system. So like we're even running advanced stuff where you can have listening agents, so I could have a manager listening to somebody, giving them one-way feedback. All of those features are now available on cloud voice systems. Our headquarters corporate office, where everyone actually works out of, is just 2 redundant internet connections out. That's it. There's no servers or systems or anything inside of our office. If you hop on our network with us there at the office, like you're going to be on the network with our PCs, but there's nothing from a security access control perspective that we worry about because we tunnel everything up to different cloud systems.
Yeah, we're left with the telephone system on premise. I'm also looking, I want to do away with my data center.
Yeah.
We have 1,100 employees, so we're pretty big. So I'm looking for a firewall as a service too. So I don't know if any vendors provide that.
This question was trying to get out of the data center to get to a firewall as a service. So there's a number of vendors that make security solutions that run across all of the clouds. If you were looking to move to one cloud individually, each of them have very granular security access controls that you can set up and configure. All the things you can do on a firewall you can do through the security and access control settings on each of the big 3 cloud providers at this point. But then there's also third-party services that run as server-side firewalls where it's a whole VM, or as agents that turn each server and give them their own local firewall.
Because I look at Azure, you can spawn Palo Alto VM, or
Yep.
Microsoft has their own firewall. But the problem is consumption. They can't tell you how much it's going to cost you to reroute 1,100 employees.
Yeah. So the question is pricing and cost on some of the stuff in the cloud is complicated because if you have your own data center, you've got 1,100 employees, you already know how much the data center costs. You know the electricity. You know your internet bandwidth charges, and on the cloud piece. So what I would recommend in that type of scenario where you're not sure, if you have an office of between 50 and 100 employees, move that office up and run a sampled test. It's even good just from a business continuity, disaster recovery planning perspective. So like use it as part of your DR and BCP budget for this year and run a test with a small office of what does it look like if this office has to run off of a data center that's not ours now out through a cloud, and you can see both how that works from a BCP perspective and what it would cost you to scale up to the whole company.
Yeah, Azure has real good cost. Like if you want to move national servers, solid state drives, and it's fixed. If you sign a 3 contract, it's even lower. But the network speed is never guaranteed, and they're never going to tell you how much you. So that's one of the dark areas that you're going to face as an IT.
Yeah, the statement was kind of about network speed and consistency across the big clouds. Unless you're doing a really large-scale data-intensive app or they have some real big problem, all of our regular IT business apps are almost irrelevant inside of these facilities. I mean, if you just think from Google's network perspective, how much video is getting delivered over YouTube, everything else doesn't matter at that point. Like all the rest of the traffic that we can generate is all of us is less than, and by all of us I mean everyone in the world doing all of their IT business stuff generates less data than YouTube and less network traffic flow. And then on the, like you go into Amazon, they're running, Netflix is a huge customer there. They've talked about it publicly a number of times. And there's other large scale services like that running on Microsoft as well. I'm privy to one, but I can't disclose, but it's another very large real-time service like with video flow, because no one loves when your Netflix is buffering. No one loves when you go on YouTube. And I saw a little joke on the internet the other day. It was like this lady with a walker, and this is my video loading on YouTube, and then it was Usain Bolt running the 100 for my ad loading on YouTube. So like there is some joke about the network consistency piece around these, but for your business apps, the latency and things inside those data centers should be much lower.
a small person like me, like my company of 30, 35 employees, I'm not going to get diversity. I just pick Google or I pick Exchange Online.
Yeah.
What happens when those guys go down? And yet it's still important for us to have email. Like before I was using multiple. I would have like I had an on-site Exchange server, and then I had an Exchange server off-site in a data center that I could switch over between. But now I've just got Exchange Online.
Yeah, if you move to Office 365 or G Suite, you're trusting them to run a reliable service. Both of them have had outages this past year. Both of them had email queuing and delivery issues. They're going to continue to have those. Running email's hard. I ran a giant email platform for Rackspace prior to running Jungle Disk. So yeah, it's some of these where like stuff is out of your control a little bit. And this is one, if you look at business processes that are super dependent on email, and you look at failing over from your own Exchange in your data center to your failover data center, if that failover window is an hour or 2 hours or 4 hours or 24 hours to update DNS or whatever, I think if somewhere in the 4 hour plus range, if that's how long it was to take you to fail over, I would be shocked to see G Suite or Office 365 with a 4 hour plus delivery outage at this point. Now, outages less than an hour, they're going to have stuff that's going to happen from time to time still. So if your business processes can deal with email getting queued up for an hour and having delivery issues for an hour, I think you're 100% fine. If you have a business process that relies on real-time delivery of email, and I was going to move to Office 365 or G Suite, and I had a setup right now that gave me real-time failover, I would look to move that business process out of email to something else where I can guarantee real-time delivery.
It's pretty rare. We've had it for 7 years and it did that.
Yeah.
It's very rare. Don't worry about that.
Yeah, the one advantage I did find, I think, like the past year, I did have an afternoon or something where email wasn't working that well. But the advantage, I was able to go to the executive and say, well, before, if it was my server that was down, you were complaining about not being able to communicate with people out there. Now, no one's communicating. So we're in the same boat as everybody else.
Yeah.
So don't worry, they can't send you emails.
Yeah.
Well,
Yes.
a lot of our clients are using the same stuff.
Yeah. No, everyone's moving to one of those two platforms at this point, except for the super security conscious. They're running on Proton Mail. Any additional questions? Well, thank you all for hanging out and making it back out after a fun night of music last night. And if you have anything else afterwards, yeah, I'll be up here.